In this video, we're going to cover a couple of tricky interval problems that we have here in our homework. So one of them is this number 6 here. Okay, so we got inequality form, set-builder form, and interval notation. All right, and then we got a line graph on the right that we're going to fill in. So they're going to give us one of those, and we got to figure out the other three. All right, so here they give us the interval form. 5 is included to infinity. Alright, so I'm just going to pick a line here. Let's make this 5. So close dot, because it's a bracket there, so this will be 5. And then this interval goes from 5 all the way to positive infinity, which is to the right. Okay, so line into the arrow going to the right means infinity. Okay, so inequality form, the way to write this. What I usually do is I try to think of x as infinity. All right, so there is no infinities. It's very common for students to write 5 is less than infinity. Okay, no infinities in inequality. All right. However, we do know that all the x values are to the right of 5. So all those x values from 5 and up are going to be equal to or greater. Let's not forget my equal to bar, because it's closed. We need that equal to bar. All right, so basically, I just need my variable x there, or whatever variable applies to your line. So 5 is less than or equal to all the x's, okay? And then in set builder, we just kind of define the variable x such that 5 is less than or equal to x, and close the braces. Another one of those problems is number 10. All right, so for set builder, the set of x such that x is all real numbers. In inequality form, you basically just say x is all real numbers. Okay, well, fine. This will be fine too. You can just say x equals and then the real number symbol. All right, x equals all real numbers. All right, so for interval notation, it's not quite as simple. Okay, so we've got to think on the timeline. So let's pick an arbitrary point. So all real numbers is basically all the numbers on the timeline. So all the numbers to the left to negative infinity, and all the numbers to the right to positive infinity. Okay, so in interval notation, you got to remember the smallest number to the highest number. So we've got basically negative infinity with parentheses, because the infinities always have parentheses, and then positive infinity with another parentheses here. Okay, and that'll cover all the numbers. So that means all real numbers in interval notation. Okay, let's look at number 11. Here is the split situation where you have one point with the arrow going in one direction and the other point with the arrow going the other. Okay, so it's kind of a split interval. Talked about this in our notes. Okay, it basically means we're going to need two inequalities or two intervals to describe it. All right. So for the inequality, we basically have all these x's. Okay, so these are x values. All right, so the x's here are going to be less than or equal to -1. Or the x's are going to be greater than 2. Okay, now this one doesn't have a bar because the 2 has an open point there. Okay, so watch for those open points. Okay, so to do in set builder is basically the same thing. So we're just going to define x such that x is less than or equal to -1, or x is greater than 2. Close the set. So in interval notation, again, this is where the or is at. In interval notation, we use this u thing, okay, to describe that gap there. So what we're going to do is, again, go from smallest to biggest, but we have to go through all the breaks. So the smallest number to the first break, which is where the or is at, and then continue after that from the smallest number to the highest, going left to right. So for interval notation, so this one's going to be negative infinity, because the arrow goes to the left, comma to -1, bracket, because it's included, closed circle. Then we're going to put our union symbol, not or. Then we're going to use parentheses, and we got the 2 all the way to positive infinity, and that's how you describe that set.